Hi everybody, back to introduction to LTspice for tutorial again. This one, what I'm going to talk is about the Thevenin and Norton theorem. Okay, let's take a look at the circuit using our PSpice right here, just to for the clear understanding before we move to LTspice 4. Okay, so let's take a look at this one. I already have a circuit just right here. Well, this is my load, and this is my also my load. Cannot use the same name because there is not allowed by PSpice. And this one is, if you not include the load, what you see here when I highlight the rate components, there are supply, okay, which have V3 and which is the DC power supply, and you also have R3, R5, and R4. And what we're looking for is just like the simplest one. Is that when you have load here, you are looking for the most simple circuit. It's just you want to have only one supply voltage, and you want to have only one resistor. So what I mean is that we're going to convert, this part of the supply, and to be has only one supply voltage and has only one resistor, and I'll use the supply as the VTH. That's RTH stand for Thevenin, and RTH stand for Thevenin resistor as well. Okay, so whatever you do, you convert this part of your supply to be this part of your supply. The current that's flowing through the load has to be equal for both circuits, otherwise you do something wrong. Okay, I'm not going to go through the calculation, but this is impractical that you can do the measurement by using meter or whatever you want to convert your the circuit to be the circuit. So what I have just right here, the Thevenin theorem, it just say that step 1, your VTH is going to be the open circuit, or your load is going to be open load or equal to infinity, and you can calculate for RTH. That's going to be equal to V open divided by I short, when your I short is that the current from the short circuit or your load is equal to 0. Okay, so you have only two options. Now you have open and you have shorted circuit. What I meant is that when you say open circuit, that means you don't have the load. Okay, and you're looking for is that you have to look for the voltage across R4, or the voltage at this point. Okay, now what I meant is the I short. It means that you're going to short the load, or your load is equal to 0, and you're looking for the current flowing through R5, or 150 ohms. Okay, so I will show you quick. Let's start with the open circuit first. Okay, this one your open circuit. So you look for V at this point or at this node, but this may not allow you to have like floating or components. So what I going to do, I already have V open circuit, so I'm looking for V at this point or at this node. So I do simulation and I'll look for display the voltage. So I have this VTH from V3 34. I have VTH equal to V open at this point. So is VTH, my VTH is the 15 volt. Okay, next you are looking for RTH. Why I got RTH to be 250 when I have for R3, R5 and R4? You have 200, you have 150 and you have 200. Why I end up with the 250 ohms? Okay, as I mentioned earlier from Thevenin theorem, okay, you can look for RTH equal to V open divided by I short. And I forgot to mention for the Thevenin theorem, you're going to have one supply voltage in series with RTH and in series with load. That's different from Norton, right? You can look for from Google or whatever, that's going to be the current source in parallel with our Norton. But at this point I just mentioned about Thevenin theorem. Now let's do a short circuit. So our short circuit like this, or your R load is equal to 0, right? And you're looking for the current flowing through R5. So I do a simulation and I'll look for the current. So the current flowing through R5 is like 33.33 milliamp. Okay, that's why I have on my Excel just right here. We open, you have 15. You have I short. Sorry. 33.33 milliamp. Is it I did something wrong here? So I short has to be what? Okay, let's already short the circuit. Let's short it again. I don't know what's happened. Okay, so do analysis, simulate, and let's see the current. Okay, I have like 60 milliamp, or that's equal to 0.06 amps, right? So that's why I have 0.06 amp for I short just right here, and I can calculate for RTH. That's equal to V open, right? So I have B2, that's V open, divided by B3, that's I shorted. So I got RTH equal to 150. So if I take this one out and I back to the original circuit, so I do simulate and I ignore the voltage display. As I mentioned earlier, that if you do the right conversion, or like you have the supply, to have only one supply, PTH, and only one resistor, which is the RTH Thevenin, you're going to have the current flowing to the load have to be equal, right? So this have 33.33 milliamp. That's the current flowing through the load. You cannot change this one. So I already showed you how to find VTH, and you have how to find RTH. Okay, hopefully this one is clear for you. And let's go to LTspice 4. Start over again, LTspice 4, and I go to new schematic. I will draw the same circuit. So let's get to DC supply voltage. Okay, I need this one to be what, 30, right? So you take a look at the circuit in PSpace. You have V3 and you have 4R, right? And have only R5 to be 150, and the rest are like 200 ohms. Let's do that quick. So I need ground. I need R. So I need R in vertical. Vertical, that's for the load. And I need R in horizontal. So I control R. And I need another one here. I would like to change this one to be alert. Okay, so you move cursor around here and right click. You change R2 to be alert. The rest is not necessary for you to change. And you want to change this one, change the value R4. You go to the device, right click, and do this one only 150 ohms. So the rest is 200 ohms, right? I don't have to type that again, so I control C, and I go to the device. I'll control V to paste, and also R1, control V. Okay, and now the last step, make connections. And you have to practice, oops, I can't undo. Alright, let's make connection again. Almost finished. Alright, so you have the circuit same as what I have in PSpace, just right here. Now what you're looking for is you want to look for V open, right here. So you need to label, or you need to add reference. So I'm gonna add reference just right at this one. By doing that, you go to edit, you go to label net. So just put A, whatever you want to put it in. And you see that you have the yellow line here on the line that you want to put this as the referenced node. You make a left click of your mouse to place. And as I mentioned, you look for V open at this point, so you have to open alert. You just use the scissor to cut alert, and you also have to cut this one. And the next step, you look for VA, right? So you go to edit, and you go to PSpace analysis, and you go to a DC operating point. You click OK, and you left click to place the box. And now you're ready for a simulation. You go to run, and then it should pop up to give you a VA go to what, 15 volt, right? Same as I did in PSpace. So this one, your VA is 15 volt. Okay. Next, let's get to I short, right? So I undo again to get all components back, and I short the whole circuit. Yep. So it's not allowed. Let's try again. You have to connect all the way to nope. Okay, doesn't matter. I just cut it and I make short circuit just right here. So now you look for the current flowing through R4, which is the should give you what 0.06 amps. Okay, let's take a look. And my operating point box is disappear, so let's get it back just to make sure that this will give you the current and the voltage. So we are ready to do a simulation, so let's go to run. That's supposed to give you what again 0.06 amps, right? So that's going to be the current flowing through what 4. So that's the 0.06. You don't have to care the minus sign, because as I mentioned, this is just only show you apply KCL at this point. So I got the same result as the from PSpace, right? I short it equal to 0.06, and you can get RTH equal to V open divided by I short. So that's give you 15 divided by 0.06. Let's give you 250. Okay. So that's about Thevenin theorem by LTspiceIV. Okay. I'll see you later. Bye.